Good morning. Today we are going to see asymptotic analysis. Asymptotic analysis evaluates the performance of an algorithm in terms of input size independent of any hardware or implementation details. Example, linear search. In worst case, in linear search, when searching an element for an element, the worst case will be the element not to be found in the list. The best case is the element will be found at the first index. The average case will be the element will be found at the middle of the list. Next, the asymptotic notation. The asymptotic notation is the mathematical tool to describe the efficiency of an algorithm, particularly in terms of how their execution time or space required grows as the input size increases. It is a way to analyze and compare the performance of algorithm without being tied to any specific hardware or implementation details. There are majorly three notations in asymptotic notations. The first one is Big O notation. The Big O notation represents the upper bound of an algorithm growth rate, which is the worst case. That means the maximum time or space an algorithm takes to execute. It is denoted as O of f of n, where f of n is the function of number of steps an algorithm performs to solve a problem of size n, given two functions f of n and g of n, where f of n is less than equal to c star g of n. There exists constant c greater than 0 and n naught greater than equal to 0, such that c star g of n for all n greater than equal to n naught. This is the diagrammatic representation of the Big O notation, where the time complexity t of n in the y-axis and the input size n will be the x-axis. So the Big O notation grows as such in the diagram. Next one is omega notation. This omega notation represents the lower bound of an algorithm's time complexity, which is the best case, and it is denoted as omega of f of n, where f of n is number of steps executed to solve a particular problem, given two functions f of n and g of n, such that f of n greater than equal to c star of g of n for all n greater than equal to n naught, and the diagrammatic representation of omega notation. Next, the theta notation. It represents the average case, which means it bounds both the upper bound and lower bound time complexity of an algorithm, and it is denoted as theta. A function f is said to be theta of g if there are constant c1, c2 greater than 0 and the natural number n naught, such that c1 star g of n less than equal to f of n less than equal to c2 star g of n for all n greater than equal to n naught. And this is the diagrammatical representation of theta notation. We have another two notations which are called little o notation and little omega notation. Little o notation denotes the strict upper bound, means the function growth is strictly less than another function. Little omega notation denotes the looser lower bound, indicating the algorithm growth rate is strictly greater than another function, whereas big omega notation represents tight lower bound and little omega notation represents the looser lower bound. That's all about the asymptotic notation. Thank you.